Hey everyone, and welcome to Thwack Camp 2022. Can't believe it's already been another year, but first of all, thank you for joining us today to level up your database game. My name is Rob Mandeville. I am a solution architect here at SolarWinds, and I'm joined here today by Ash Rexseedler. Ash?
Hey, Rob. Yeah, thanks. So just like Rob, I'm also a solutions architect, and both of us in a prior life were kind of hardcore DBAs, database developers. We've been doing databases for too many years, but it's nice to meet everyone.
Yeah, more years than we want to admit, right? So today we're going to be walking through a specific situation with using Postgres as one of our examples, but really this could be migration from any platform, any relational kind of database to any other kind of relational database. We're picking Postgres actually because it may be kind of key or on the horizon for you guys as you're doing your database journey. A lot of times, IT organizations are focused on total cost of ownership and making sure that they are, delivering the same value to their end users, but trying to do so more cost effective. So one of the key elements here is one thing we're going to cover here is weight-based analysis. And what that is really looking at your systems and determining, am I executing or am I being suspended by some other kind of activity? Right? So really the base concept of weights are that I am being suspended by things like waiting for a lock to be released by another process, waiting for IO to complete successfully, things like that that are not actually going into the processing or execution of our SQL statements. So by focusing on that and making sure that we have a good, effective way to remove those bottlenecks from our system, will really ensure that we're maintaining that excellent quality of service that we're delivering to our end users. If we use the weight analogy as a good proxy to what our end users are experiencing, or kind of that quality of service as a delivery from a database perspective, then I think that gives us a really good idea and true north kind of metric as far as, hey, how should we be determining if we're successful in making sure that when people are accessing our database, if things are successful or not? So really, when we're talking about weight analysis and using that as kind of our true north as far as performance of delivery or quality of service delivery to our end users, it becomes a really good proxy to make sure that we're doing our job as far as database access goes. So that's why weight should be important to you, regardless of the database platform that you're monitoring, be it Postgres, Oracle, SQL Server, things like that. And really when I first launched my career into database technologies and stuff, I was actually trained to do things like, hey, if there's a performance issue, go look at CPU utilization, go look at memory. Is it healthy? Am I saturated? Go look at disk IO latency, things like that. So this may be a little bit of a paradigm shift to some consumers out there to really change the game and really start to look at things from the end user perspective versus system utilization and resource usage. So that's really where the weights become very important to you as both a provider of this database service, as well as making sure that, Ash in accounting, if he wants to go to lunch with his friends, he doesn't want to wait for that report to complete, right? So he wants good service for sure to make sure that he's not late. So one thing that I wanted to communicate also is just a personal experience that I had in migrating from Oracle to Postgres. And again, it could be from any relational database system to Postgres. I worked for a satellite imaging company, and we wanted to stand up a public-facing service so people could self-serve, go ahead and purchase products without even getting sales involved. In doing so, though, we worked with our Oracle representatives, and it was definitely going to be cost prohibitive from, standing up that site because we couldn't even tell them how many end users we might have at any given point in time. So what we did was we had to look for alternatives, and it seemed like Postgres seemed a really, really good fit at that point. In fact, we had a geospatial component as well. So the PostGIS feature within Postgres really lent itself as being a nice geodetic representation of the Earth as a model. So we had to port basically our backhaul, our ground system from our satellite imaging to Postgres from Oracle. So that was, really presented a lot of challenges on our end as far as making sure that functionality was the same, making sure especially like performance was the same or maybe even better, right? Going from Oracle to Postgres. So if you guys have similar situations like that where you're running through, maybe it's being dictated by the CIO or something like that, or somebody, VP of IT, as far as, total cost reduction. And that may be a common reason why people are moving to open source. Very similar to us, right? It wasn't affordable with the price point that we were at. So we wanted to make sure that we were able to successfully stand up this external facing or public facing system. So that was my own personal experience and everything. And now I think I would like to turn it over to Ash, who's got some more examples of doing a migration from, maybe some of those proprietary type database systems to open source.
No, hey, thanks, Rob. No, great information, and actually a fantastic segue into my portion. So thank you for that. And like Rob said, and regardless of your role, you're more than likely, just like Rob, already planning he's already done a Postgres migration, but you might currently be in one, or your company is planning one for those cost savings. Right now, I'm showing you a slide of the migration process, and if you're already in this stage or planning it, you're probably familiar with some of the stages in this process: assessment, schema migration, data migration, functional testing, performance testing. And instead of spending a lot of time, because Google's your friend, you can find a lot of white papers online. For example, EDB has a comprehensive checklist that covers a lot of the details specific to Oracle. And for that reason, I'm not going to spend a lot of time on this slide. Instead, I'm going to focus on two specific areas, and that's going to be the functional and performance testing sections. And specifically how Database Performance Analyzer can help your team reduce the time that you spend validating and tuning your new Postgres environment before doing the actual switchover. So even if you're not a Postgres expert. So the main goals of the functional testing stage are to verify that the new Postgres workload is fully functional by testing the new application logic against the new schema to identify any functional issues that you may be having. And then once those functional issues are resolved, we need to make sure that the new Postgres environment is configured for optimal performance as it relates to that specific database platform that you're migrating from. So you might be migrating from Oracle or SQL Server, an application. You need to test and measure how performant and functional is that existing application. And at the same time, you have to then measure the new Postgres environment. You need a tool to do that. And as you'll see, with the help of DPA, and weight-based analytics that Rob did a great job explaining, our team was able to achieve some truly amazing results, which I'm excited to share with you right now. As I was putting together this presentation, I was struggling trying to condense what's normally a 30-minute presentation into a buttoned-up 10-minute package summarizing our 23-day Postgres journey. It needed to be concise, to the point, and at the same time contain meaningful technical information. Where I landed is this report that you're seeing right now that I created using DPA's reporting features. And it really highlights, number one, the top chart. You're going to see the average execution speed of our main queries. And as you can see from this chart, our average execution times improved tremendously. So on January 11, and we're going to get into more detail a little bit later on, but you can see average execution time of this one update statement was 5 milliseconds. And if you move to the end, you can actually see this one particular query improved to 0.107 milliseconds. That is a tremendous improvement. And when you look at the cumulative values of all of these queries, our overall performance was 13 times faster, or to sound more impressive, improved by 92%. So we'll use the 92%. So while that top chart is very impressive, the chart below is the heart of this story. So in the bottom chart, you'll see our top weight events that we use to guide us on our Postgres tuning journey. And if you look closely, you'll notice two colored slices. One is a light purple, so the IO data file read. One is sort of this teal color, IO data file read. And these were the primary top weight events that we saw during our tuning journey. And you'll notice that something epic happened on the 19th. We completely eliminated these two weights. How did we do it, you ask? Well, let me tell you. So what's great about DPA is not only is it recording the actual workload of the application, which is critical when you're doing a Postgres tuning project like this, but it also has embedded expertise that was absolutely essential for us to achieving these epic goals. So if you look at this particular weight, if you're not familiar with weight-based analytics, or even if you are, each platform is slightly different. So DPA tells you not only what the weight event is, but then who do we get involved and possible solutions. So as we went through this, we really needed to get the storage admin system administrators together, along with myself, the DBA, and the developers to really get this database to the next level. Once we went past the 19th, things were looking fantastic. Even if you look at the average execution speed, we're probably not going to get fired at this point, but we wanted to take it to the next level. So we continued using weight events to sort of guide us. And at this point, if we looked at the documentation, we were able to determine we really needed to turn things over to the developers, which were then eventually able to make code changes, which led to kind of our best performance at the end of our journey. So what I'd like to do now is I'd like to kind of go through the details. So I'm going to go up here to home, and I'm going to go through this timeline. And I use DPA's annotation features, which are fantastic to kind of track and document what you've done, what you're doing, what's changed, what's good, what's bad. You'll notice that I like using the average weight. That was sort of the report that I just showed you. It's in the main dashboard of DPA. Great view. But day one, worked with the system administrator, spun up a Windows VM, downloaded Postgres 14, installed it, used the default configuration. Remember, I'm an expert in Oracle or SQL Server. I'm new to Postgres. What am I going to do? I'm just going to take the defaults and hit next, right? Then we did a basic workload test to see what is the performance using the defaults. And as you can see, they weren't great. The next thing that we did was there's this cool little tool called pgtune that if you're new to Postgres, it's kind of a neat little online utility. You can Google it. You just put in your operating system, how much memory, how much CPU, the type of application you have, and it'll use best practices to give you configuration recommendations. So that's what we did. We actually used that. I also created, using my knowledge, past database knowledge, I separated out the write-ahead logs, the WAL files that they're called, similar to SQL Server's transaction logs. I split those out into a different one. So I worked with the storage admin on that. And as you can see, we ran another workload test, and we greatly improved performance. Actually, this is a great story right here when you look at the initial and where we're at just with those basic configuration changes. But we still had a lot of I/O issues. Now, had I swallowed my pride, I would have continued to work with the system administrators and the storage administrators. But instead, what I did is the next day, I said, okay, well, the I/O weights, I need the team for that. So I'm going to focus on other weights. So I went to the next weight in line, which was this LW lock buffer content. Again, the documentation in DPA had me focus on literally, it's a parameter that you can adjust in Postgres. So what it does, it's a fill factor. So DPA revealed that we had a lot of inserts. We had a lot of updates that were going on. It also pointed out what tables were kind of the hot tables, right, in the application, which is really imperative when you're tuning. But this fill factor, when you set it, you can literally tell Postgres to save some space for the update statements. So instead of opening up multiple or accessing multiple data files, it's only accessing one. And what this did is it really eliminated a lot of locking. And it also improved the performance of those update operations, which was a big portion of our workload. So that was very significant. At this point, I am feeling fantastic. I'm kind of a little, giddy here. So I went, okay, I can do this. So I kind of deviated from weight-based analytics, and I started Googling and started researching like a lot of you will do. And one thing that I Googled was that for Windows operating system, Postgres does double buffering, right? It really relies heavily on the operating system. And there's a rule of thumb for Windows only that if you set the shared buffers in Postgres to 512 megabytes, what you do is you pass the page caching to the operating system, in this case Windows, because it does a better job. So that's what I did. Guess what happened? Performance decreased. Our best performing configuration was still on the 14th. Again, I continue on my merry way, deviate from weight-based analytics, start focusing on various configuration parameters, not knowing what they're really doing. And as you can see, I wasted a whole lot of time. And then finally, I swallowed my pride. And this was the big moment on January 19th, when I really engaged the system administrator, the storage administrator. We once again focused on weights, the data file read, the data file write, documentation in those two wait events. But in the main report that I showed you in the beginning, what we did was we literally saw that if we could get the active data set in Postgres to run in memory, we could basically create an in-memory database. But you needed to understand, I needed to understand, well, what was the active data set? DPA let me know that. So what it led me to doing is actually deviating from best practices, configuring the shared buffers to 75% of total memory. That's what we needed. Now, we could have added more memory, but let's just say we're on a tight budget, increased it to 75. The system administrator, we did some testing as far as page caching on the Windows side. Don't ask me about that. That was in their area of expertise, but they made some changes. Also, the data revealed that we really didn't need to configure workmem. So workmem is utilized for sorting. And by looking at DPA, we had a lot of updates, a lot of inserts. We had some select state, limited sorting, so we could reduce that. And in Postgres, what it'll do is that's a setting that tells Postgres to allocate that much memory for each operation. So by reducing that, we really freed up a lot of memory that could be used for other operations. The storage admin determined that the block size really didn't play a factor as far as our wall block size and buffer cache and the operating system block size, as long as it was a divisible. We also looked at our checkpoints. The storage administrator determined that every time Postgres was doing a checkpoint, there was a lot of disk contention. So then we focused our energy on that. And what we did is we actually increased the max wall size so that it delayed when Postgres would do an automatic checkpoint. And then we forced Postgres, because of our SLAs, to always do a checkpoint every hour. So that was a significant configuration change to reduce I/O. Another significant change to reduce I/O was actually using wall compression. Wall compression really reduces the amount of I/O because you're not writing as much data to disk. But keep in mind that it takes a lot of CPU horsepower for Postgres to do that. But we actually, in this particular case, kind of had some additional CPU power. The other thing that we did was we really took advantage of PG Bouncer to sort of manage the connections. Again, all related and tied back to DPA's weight documentation. So we're really happy. So we ran some workload tests over the weekend. But this is the point where, again, remember that one wait where we were then getting the developers involved. So Monday comes, we engage the developers, we show them the documentation. They started changing their code, and what happened? Actually, performance degraded. It got worse. And that can happen. But why do we know that? Well, we have a tool called DPA that's recording everything, and we knew that it was getting worse. But what was significant here was understanding the workload, right? What tables were involved? What was getting, what objects were causing other objects to get blocked? DPA revealed all of that information. Taking that data, the developers were then able to modify the code, and they were able to hone in and make this application run pristine. Then what we did is we started running a workload test. And what happened is during that workload test, right, that's why we need continuous monitoring. We ran that workload test and we saw a slight decrease in performance. Again, this was on a Friday, go figure, right? So we saved it for the weekend, came back on Monday, again, looked at DPA, and it had us focusing on tuning auto vacuum and fill factor. Now, you don't want to really mess around with auto vacuuming. Postgres will have, they call it tuples, which are rows. Tables are called relations. And what happens is it keeps a snapshot of all these rows, and you can have what's called dead tuples, and they have to be cleaned up. They have to be vacuumed. And you don't want to do too much vacuuming or little vacuuming. There's this fine line. And you can set and adjust vacuuming at the instance level, or Postgres calls it the cluster level. And what we were able to do is focus on one particular table. It was our history table. That didn't really matter, so we're able to sort of adjust that. And as you can see, once we did that, and we ran we almost ran over 500 million transactions testing, you can actually see that our performance went through the roof. Not only did performance go through the roof, but you can see that DPA has these great resource metrics that also has embedded documentation that can show you how efficient is that workload. You can see our transaction rate really high. The efficiency you can see throughout the journey. Our goal is 100%. Fetch versus returned rows. That is phenomenal. And that's what we were able to achieve. Our checkpoint ratios, the goal was to sort of get that down to 0. Phenomenal. Just a fantastic journey. And with that, I'm going to wrap this up. Hopefully this was beneficial to everyone. I'm going to hand the baton back over to Rob to take us home. Rob, it's all yours.
Ash, that was phenomenal, and thank you for running us through, your story and migration from one platform to another. A couple of things that really jumped out at me during your walkthrough of your journey here is really, first of all, understanding your workload. Understanding the application, how it's using and accessing the data, and for you to be able to kind of dial back the work mem space that was actually you thought maybe required for some sort operations, order by clauses, things like that, was really not needed, right? So you were able to kind of steal from Peter to pay Paul in that regard, as far as giving the memory more to the buffer cache.
Yeah, absolutely. And Rob, one thing, I'm glad you brought that up, because there were some key takeaways here, lessons learned with this journey. And I kind of have it, again, the annotation features are fantastic. Number one, Postgres out of the box is configured for stability, right? It's not configured for performance. And I think people need to understand it. And the reason being is you can install, it's cross-platform. You can install it on Linux. You can install it on Windows. The other thing that we learned is that Postgres, compared to other databases, really relies heavily on the operating system and the storage layers, right? And that's why we had to bring in the storage and system administrators, and we needed their expertise. And it also, to your point, I'm glad you brought it up, is that one configuration for one application doesn't work for another. I could take this same configuration through this journey, use it in another application, and I'd have terrible performance. So to your point, you really need to understand that workload when you're tuning Postgres. One size does not fit all.
Absolutely. And understanding that tight coupling between the database system and your operating system is really key to success. And I your journey is fantastic in the standpoint that, you're bringing in all these different IT disciplines. You're working with your storage admins, your sysadmin, really understanding the Windows operating system too, to understand how it's going to be leveraging the memory constructs and stuff. I think is just a fantastic story. And folks, I think what we're talking about here is making sure that we're doing the right thing by our end users, by our customers, to make sure that, again, this quality of service is not degraded, right? So I'm coming from maybe a proprietary system like SQL Server or Oracle, and then now I'm moving to open source. We want to make sure that they get that same level of great service from the database tier that they're used to. And as far as that goes, I mean, having some kind of visibility into your systems to make sure that quality of service is being maintained is key. So I think this is a great example of, both anecdotally from my own, personal story and Ash's journey here. I think it really gives us a good idea of how we can ensure that things are not just functional, but continue to be performant going forward.
Yeah, here.
Yeah. So Ash, thank you so much for sharing that with us. And
yeah, thanks.
Yeah, no, fantastic. And, a lot of you may find yourselves in a similar situation where, maybe you're not choosing to go to Postgres or MySQL or other open source systems, but you may find yourself having to support them nonetheless. So I think it's kind of critical to make sure that you have eyes on the environment and make sure that you can, be successful at your job in delivering that service that you need to. So thank you all for joining us today. Hopefully this was beneficial and informative. Thank you very much for spending some of your, very valuable time with us. Ash, thank you.
Yeah, no, thanks, Rob. Yeah, thank you, everyone. And hopefully you enjoyed the journey we took you on, and hopefully you found some gold nuggets that were beneficial that you can take in your everyday journey. So thanks, everyone. Take care.